Assalamualaikum and greetings everyone. I am Ahmad Ulwan with Zulfikri Alhapiz with matrix number 73299. We are from Group 2 to represent our open-ended lab, which is water level indicator system. Our group consists of 3 members, Aziz, Binti Aidell, Abdul, Aziz bin Shamsudin, and me, Ahmad Ulwan with Zulfikri Alhapiz. In today's video, we will cover 4 main parts of our project, which is introduction, result, discussion, and conclusion. Without further ado, we will begin our presentation. First of all, what is water level indicator system? A water level indicator system is a system that relays information back to a control panel to indicate whether a body of water has a high or low level. In this open project, our group decided to develop a system called water level indicator system by applying the analog electronics concept. Upon the completion of this project, we will be able to understand in more details regarding analog applications by analyzing and observing the process of this system's development. Moreover, this system is developed through proper software to simulate a simple indicator that can be used by the community to indicate the water level, such as to measure the river as a flood prevention. Recently, our country is being hit by an unexpected flood that happened in most states, especially in Peninsular Malaysia. Surprisingly, the places that are affected are uncommon places where the flood usually occurs. Hence, the system is developed to overcome this problem by alerting the people surrounding about the river status. Thus, they can take a precaution measure to be prepared for any possibilities. Therefore, there are 3 main objectives of this project. The first one is to understand the applications of analog and digital electronics principle in real-life situations. The second objective is to simulate a water monitoring system that can indicate automatically. And the last objective is to develop an analog system that benefits the community.
Hi, my name is Aziz bin Shamsudin with the number metric of 73285. So for my part, I will present to you the list of components, schematic diagram, PCB layout, 3D visualizer from top and bottom views, as well as the results. So without wasting our time, let's take a look at the list of components. So all of these components are needed in order to complete the system. So for the first component here is the transistor with the number series of BC547, where we need it for 4 units. Then the second component here is the resistor with the resistance of 330 ohm, where we also need for 4 units. Then we need 1 unit of red LED, 1 unit of yellow LED, 2 units of green LED, 1 unit buzzer, and 1 unit DC power source with the 9-volt Aidell battery or power supply. Now let's take a look at the schematic diagram. For this experiment, we have been choose to use the Proteus software because the software can create the schematic diagram, PCB layout, as well as 3D visualizer from any views. So now we will focus on this schematic diagram. As you can see here, the transistors, resistors, and LEDs are placed in parallel between each other. This is because if any of LEDs, transistors, or resistors has been broken or having any problem, this system still can go on. So the broken component will not affect the system. So here we assume that the water level is a water tank. So in this water tank, we have been label it into 4 stages, which is level 1, level 2, level 3, and level 4. So if the water has been reached level 4, the buzzer here will be ring or will sound to alert the people surrounding. So from the schematic diagram just now, we can create the PCB layout. So this is the PCB layout that been created. So as you can see here, all the transistors, LEDs and resistors have been placed in a line because we want to make the arrangement of the components become tidy in the PCB. So here is the buzzer, and B1 here is represent the power source or battery. So for the 4 holes here is to connect the wire to detect the water level in the tank. Now we will go for the 3D visualizer. So this is from the top view. So as you can see here, the transistors, LEDs and resistance has been placed in line to make it become tidy. So this is the place where we want to put the buzzer. So B1 here is represent the battery or the power supply. So this is the 4 holes that I just mentioned. So this is the 3D visualizer from the bottom views. As you can see, we more focus to the bottom copper compared to the top copper. As you can see from the top views, the top copper we only use at the resistance here, then connect to the battery, then from the 4th transistor to the first hole, and then from the LEDs, from D1 here connect to D2, connect to D3 and connect to D4, and from buzzer connect to transistor 1. So the others will connect with the bottom copper. Now we will go for the results. So when the water has reached level 1, as you can see here, the first wire here has been connected to this wire. That means it's already reached the level 1. So the green LED here has been light up because the water has been reached level 1. So for the other LEDs are not light up because the water still not reached their wire yet. Then when the water has reached level 2, as you can see here, the second wire has been connected to this wire. That means it has been reached level 2. So the second green LED has been light up, and this shows that the water level has reached level 2. Then when the water has reached level 3, as you can see here, the wire here has been connected to this wire. So the third LED, which is the yellow one, has been light up, and this shows that the water has reached level 3. And people should cautious from this time because the yellow LED has been light up. When the water level has reached level 4, which is the dangerous level, as you can see here, the 4th wire here has been connected to this wire. So the red LED has been light up. That means the water level has reached the dangerous level, and it will be risk for the people surrounding. At the same time, when the red LED has been light up, this buzzer will be sound or will be ring to alert the people surrounding about the water level has been reached the dangerous level. To summarize the results, so when the water level has reached level 1, only LED number 4 has been light up, which means D4 here. So when the water level has reached level 2, the LEDs that only light up is D3 and D4, which are both of them are green LED. So when the water level has reached level 3, the LEDs that light up are D2, D3 and D4, where D2 here is the yellow LED, D3 and D4 is the green LED. So when the water level has reached level 4, so all the LEDs are light up, which are D1, D2, D3 and D4 here, where D2 is the yellow one, D1 is the red one, and D3 and D4 is the green one. So now let's take a look at a video where it shows how the system is worked. Before that, I recommend to you to volume down your device because in this video the the sound of the buzzer maybe hurt your hearing. So you can volume it down first. Alright, now we will watch this video. So as you can see here, from our schematic diagram just now, we have been create the system on the breadboard. So this is a wire that will measure or detect the water level. But before that, during this time, you don't turn on the power source yet because it's very dangerous. So now I will turn on the power source. Then I will take the water and pour it into the cup. Please watch the LED here. As you can see, when it reaches level 1, the green one has been light up. Then when it reaches level 2, the yellow one has been light up. And when it has been level 3, the buzzer has been sound and the red light will light up. So this is how our water level indicator is working. So the buzzer here will sound to alert the people surrounding about the water level. So that's all for my part. So the presentation will be continued by my group member.
Hi, my name is Binti Aidell with the metric number of 73282, and I'll be doing the discussion part. So this experiment is conducted to design and simulate a water level indicator system. We believe that the system would give benefits to the community as it can be done by anyone easily without a huge cost. A water level indicator system is a system that relays information back to a control panel to indicate whether a body of water has high or low level. There are 4 levels, which are level 1, 2, 3, and 4. Level 1 refers to low, level 2 refers to medium, level 3 refers to medium-high, and level 4 is high. In a water tank indicator system, level 4 refers to when the tank is full. If the water level rises in the tank, then the water comes into contact with probes which are adjusted according to desired levels. Whenever the water rises, we get alerts on particular levels by observing the LED lighting up and the sound of the buzzer. The condition is the buzzer will only sound when the water reaches level 4. The leftmost wire in the tank, it must be longer than the other 4 wires since it is connected to the positive voltage. So we use transistor of NPN type as the switch. The transistor Q4 is first turned off since no voltage is applied to the base and no current flows through the collector and emitter. Hence, the LED is turned off. When water reaches level 1, the positive side of the battery is connected to the base of the transistor Q4 through the water. As a result, when a positive voltage is applied to the base of transistor Q4, it enters the on state and current flows from collector to emitter, and the green LED D4 lights up. When water level reaches level 2, a positive voltage is applied to transistor Q3 and Q4. It turns on and current starts flowing through LED D3 and D4 and both these LED glows. With the same principle, yellow LED D2 lights up together with LED D3 and D4 when the water level reaches level 3. Finally, when the water level is highest at level 4, the circuit with buzzer is completed, and the buzzer begins to beep. The red LED D1 together with D2, D3 and D4 lights up.